Hi students, welcome back. Let's continue with the techniques for improving pipeline processor performance. In the previous video, I explained one of the technique for improving pipeline processor performance is instruction execution phase. So I had recorded almost 3 to 4 videos on only the instruction execution phase by taking different example students. So if you didn't watch that video, go and watch that video. Okay, now coming to the second technique. The second technique for improving the pipeline processor performance is mechanisms for instruction pipeline. There are different mechanisms for instruction pipelining which are helpful for improving the pipeline processor performance. Our main motto here is we have to improve the pipeline performance. Okay, so that the instructions can be executed without any delays and without any problem. That is our main motto. So for that, we are learn the concept of instruction execution phases. So in each phase, how the instructions are executed so that we can avoid the traffics and so that we can improve the pipeline processor performance. So coming to the mechanisms for instruction pipeline processor is prefetch buffers, multiple functional units, internal data forwarding, hazard avoidance. So these are the 4 different types of mechanisms for instruction pipelining. These 4 will be used. Why we are using these 4? Because to improve the pipeline processor performance. That is our main motto. That is what I said. Okay. So let's discuss one by one. First, we will see about prefetch buffers. What do you mean by prefetch buffers? We all know that buffer is nothing but storage. It's a temporary storage, only getting the data. A prefetch buffer, since you are getting the data from the memory and you are storing in the buffers, okay, so that the pipeline processor can be executed in a smooth manner without any waiting. So that is the concept of the prefetch buffers. So it is used to store the data temporarily before sending to the instruction pipeline. So when we are talking about the prefetch buffers, first let me explain you about the prefetch buffers in detail in this video. So here what we have to think about, what type of buffers. Okay, let me repeat again. What type of buffers are used to match the instruction fetch rate to the pipeline consumption rate? So here we have to keep the concentration on buffers. What type of the buffers you are using? So that it has to match instruction fetch rate to the pipeline consumption rate. Okay, so what type of buffers we have to use to match the instruction fetch rate? Instruction fetch rate means you have to fetch the data from the memory. So this is the memory. So from the memory unit, we have to fetch the data. So whatever the buffer you are using here, this buffer has to match the instruction fetch rate to the pipeline consumption rate. So here whatever the prefetch buffer is there, later it is sending to the instruction pipeline. So it is sending the instruction pipeline. So at a time it can't get and at a time it can't send. So it should be some matching should be there between these two. Fetching the data and sending the data to the pipeline instruction. So there should be the match should be there. A consumption rate and the instruction fetch rate has to be matched. So that the data can be moved in a smooth manner without any conflicts. That is the main motto of the prefetch buffer. So, and the selection of the buffer is also very, very important. So, generally, there are 3 types of buffers used to match the instruction fetch rate to pipeline consumption rate. What we have to do? We have to match the fetching the data from memory. It has to match the pipeline construction rate. So, for that, there are 3 types of buffers. We need to select the buffer, right or wrong? Yes? Yeah. What type of buffer you have to select? In the market, we are having 3 types of buffers. One is a sequential buffer. One type is a sequential buffer. And the second type is the target buffer. And the third one is the loop buffer. So this is a buffer selection. So you have to select the buffers based on your user requirement. Okay, so now let's discuss one by one. Before going to explain the each one sequential buffer, target buffer and loop buffer, let me explain you with a small diagram. So here I am writing while explaining. Okay, so this is a memory unit. What is our concept? We have to get the data from memory, and the data has to be sent to the instruction pipeline. So memory, from the memory the data has to be fetched. So this is a fetch unit, right or wrong? So getting the data from memory, so fetch unit. Now the fetch unit, here our main buffer concept is occurring. Whenever we fetch the data, that data has to be placed in the prefetch buffers, right or wrong? Okay, so for that there are a different buffers are there. This is a sequential buffer 1 and a sequential buffer 2. Okay, and coming to another type of buffer, here is a target buffer 1 and target buffer 2. I'll explain what this buffers. Okay, so data that is switching from the memory, that will be distributed to sequential buffer and the target buffer, and later from the sequential buffer and as well as the target buffer, those data will be sent to the instruction pipeline to perform the operations. Okay, this is instruction pipeline. Okay, so if you take a single memory access time, suppose if you are considering with a sequential buffer, a single memory access time, a block of consecutive instructions are fetched, and placed into the prefetch buffer. So here I had used sequential buffer and the target buffer. What it mean? What it will do? Sequential buffer, a sequence of instructions indicated by program counter. Generally, whatever the sequence instructions are there, those are indicated based on the program counter only. What instruction that has to be executed next. Whereas the target buffer, here the instructions from branched location. So whatever the instructions that here appear in the target buffer, they are from the branched location. Now coming to exact point, what do you mean by this sequence buffer and the target buffer? What type of data we are storing in the sequential buffer and the target buffer? Actually, the sequence of instructions are loaded into a pair of sequence buffer. Here the in sequence will be there. So that will be sent to in sequence pipeline. What do you mean by that? I'm saying that a sequence instruction is nothing but a simple, let's take simple program. Suppose A is equal to B plus C. So send the data of A and the B, and then perform store the values of A and B and C and perform the operation, addition operation. Everything will be in sequence manner. So load A, okay, load A, load B, load C, and then add B plus C and move the value to A. So everything it is going in a sequential manner. And coming to the target buffer, what type of data will be stored in the target buffer? Instruction from branch target are loaded into pairs buffers for out of sequence. That is just like a jump. Whenever the jump instructions are there, a program is a sequence of steps is there. Suddenly a jump instruction will be appeared. Jump to the 2020 location. The controller will goes to that particular 2020 location. Again, after completion, it come back to the main program. So here, whatever the sequence of steps are executing, that will be stored in the sequence buffer. And whenever the jump condition will be there, that jump condition, that will be stored in the target buffer. This is the main concept here. And both buffer operates in the first in, first out. Remember student, both are operated in first in, first out. Whatever the data that is coming first, that will be sent to the instruction pipeline. From each buffer pairs, one may be used for load instruction from memory and another buffer may be used for feeding the instruction into pipeline. So here the sequence will be, sequence buffer will be used to feed instructions into pipeline, whereas the target buffer, whatever it is used to load the instructions. So this is what it is doing here. So that it prevents the collisions between the instruction flowing in and out. That is our main motto here by using these buffers. It's prevents collisions between instructions that are getting from the memory and sending to the instruction pipeline. It's a flow in and out pipe. Because of the in and out of pipeline, there is no collision between the memory accessing. And coming to the loop buffer, what do you mean by this loop buffer? Sequential buffer, instructions are storing in a sequential manner. That type of data will be stored in sequential. And target means whenever the conditions are arise, that conditions informations will be stored in the target buffer. And coming to the loop buffer, a loop buffer holds sequence instructions. Let me write that point so that you will get an idea. It comes as a reference to you. Loop buffer. So loop buffer means it holds the sequence instructions in a loop. Whatever the sequence instructions are there that is getting from the fetch unit, those sequence instructions, some conditions will be on a loop. So that will be stored. That will be, the loop instructions will be stored in loop buffer. Simply note on that. As loop instructions will be stored in loop buffer. It's maintained by fetch stage. Prefetch instructions in a loop body will be executed repeatedly. That is the concept of the loop. The sequence of instructions will be executed repeatedly until what? Until iteration completes its execution. Whenever the condition is met, then it will be exit from the loop. That is what it is doing. And the loop buffer operates in 2 steps. Let me write the 2 steps so that you will remember this. The first step is what it is doing. First, it contains instructions sequentially ahead of current instruction. Ahead of current instructions. So thus it saves the instruction fetch time from memory. Okay. Saves time. Because of this it saves the time. Second step. Next is it recognize when target of a branch. So when it will recognize, when is the loop buffer is going to be recognized? Because sequential means whenever sequence instructions are there, it will be executed. Target means whenever the jump conditions are there. But then when is this loop buffer will be recognized? It recognizes when target of a branch falls within a loop boundary. Within a loop boundary, then only this loop buffer will be recognized. Whenever the target of a branch falls within a loop boundary, then only it will be recognized. So in this case, unnecessary memory access can be avoided. Okay, the main important here is unnecessary memory access can be avoided. If the target instruction is already in loop buffer. Suppose if target instruction is already in loop buffer, then unnecessary memory access can be avoided. So that is the use of these the prefetch buffer. So the prefetch buffers are of 3 types. One is a sequential buffer, target buffer, and the loop buffer. So I hope you understand. If you are having any queries, please give in the comments. Thank you.